For science, when we're going to do measurements, it's important to remember that we're going to do the metric system, which is based on a unit 10, instead of the English system, which may be a little bit more familiar to you. So anytime we measure mass, the base unit is actually a kilogram, but in our class we're going to use grams most of the time. For length, instead of using yards or feet or inches like you may be familiar with, for chemistry we tend to use the meter or centimeter, millimeter, any of the derivations of meter. For temperature, you may be familiar with Fahrenheit, but we're going to use Celsius most of the time, and for 1 or 2 chapters we'll have to use Kelvin, which is the actual standard base unit. And for time, the base unit is seconds. If you combine these base units, you can form what we call a derived unit. So for example, volume is length times width times height, and since that involves meter to the third, we call it a derived unit because it involves more than one base unit. Same thing for density. Density is the ratio of mass to volume, and so because it involves 2 different base units, we call it a derived unit. Derived units are something that tends to be missed on the quiz and test, so put a star by that in your notes and make sure you study that extra hard. Another example of that would be something like area, which is just length times width. Density is an important topic because it allows you to identify a substance. So let's talk about what density is. The equation for density is the ratio of mass to volume, so it's mass over volume. And one way you can remember that is if you make a heart, the heart with a line through it, that'll tell you that the M goes on top and the V goes on the bottom. The units we use for that are going to be 2 different units, so there's not just one unit for density. It's kind of like when you drive in a car and you say you go miles per hour, there's 2 different parts to that. For density, you're going to have the mass part on top, which is almost always going to be grams for this class, and on the bottom you'll have the volume part, which in this class will be either milliliters or centimeters cubed. 1 milliliter is actually the same as 1 centimeter cubed, so that's saying the same thing. And there's a visual here just to help those of you who are visual learners. If you look at the pictures, you can see that they're both the same volume, which means they take up the same space, but notice that the one on the left has more particles, which means it has a higher mass. And since it has a higher mass compared to the volume, it means the density is higher. So again, the reason density is so important is because it can help to identify an unknown substance. So for example, if you are working for the State Bureau of Investigation, the SBI, and you come across a clear liquid, one way you can identify it is to calculate the mass and the volume, find the density, and then you can see if it would be water. So water is always 1 gram per milliliter, and that's one way you can identify it. If you take a look at your reference tables, you'll notice on the first page there's a column that lists density options there, and you need to know that they'll be familiar. You need to be familiar with the reference tables and to know that they're there. So for example, if on the final exam they give you a big long question and say to identify the substance, you should look in the question and see if there's mass information and volume information, and that'll allow you to calculate the density, and then you can look on the reference tables to find out what the metal is. Now keep in mind that they're not going to tell you to go to the reference table, so you need to be familiar with the fact that they are there. In science, we also use prefixes, which will allow scientists to easily convert and represent different magnitudes of a number. So again, it allows scientists to convert and represent different magnitudes of a number. And conveniently, they're going to be based on the unit 10. And 10 is a very easy number to work with. So this is a list of the ones that we'll be using in this class. There are more than this, but these are the basic ones. Kilo, hecto, deca, then the base unit, deci, centi, and milli. And they do go in order. So for example, a kilometer is much bigger than a millimeter, which is much smaller. So they go in order from largest on the left to smallest on the right. One way you can remember these if you have trouble putting them in order is to say the sentence, King Henry died by drinking chocolate milk. Just keep in mind that the 2 D's are different. So deca is on the left and deci is on the right. Also keep in mind that the base unit is not something that you'll see. Base is put there in place of one of the units that we'll be measuring. For example, you might see meter, you might see liter, L-I-T-E-R, or you might see gram. So for example, you could have milligram, centigram, decigram, and then for base unit you would just say gram without a prefix at all. As you go from right to left on this scale, you have 10 millimeters in 1 centimeter. You have 10 centimeters in 1 decimeter. So each time you move one place to the left, you can say that you have 10 of those. If you move 2 places to the left, it's tempting to say 20, but it's based on exponents of 10, so it would actually be 100. So if you were going from milli to base unit, notice that you go over 3 spots, which means you would have 3 zeros. So there's 1,000 millimeters in 1 meter. Or there's 1,000 meters in 1 kilometer, because if you count over to the left, it would be 3 spaces. A lot of these units we don't use very often. Most scientists don't talk about hectometers, but these 3 conversions are convenient ones to memorize. So if you're not too familiar with the prefixes, if you memorize these 3 relationships, it'll help you in this class. We need to talk about measurements because for lab write-ups, I tend to see a lot of mistakes with measurements. Most students are really good at writing numbers in their paper, so they record an amount and they write it on the paper. What they tend to forget is the unit or the label. So notice that after the 25 you have mg, that tells you what you have 25 of. So it doesn't help to say 25 because that doesn't tell me if it's 25 gallons or 25 meters or 25 grams. So it's important to have the label after it. So what I would encourage you to do when you do a lab write-up for my class is to, before you turn it in, make sure you scan the lab write-up for numbers, and any number that does not have a unit, make sure you fill that in before you turn in your lab. We also need to talk about how to use this instrument that I have here on the slide. It's called a graduated cylinder. Graduated cylinders are the only pieces of equipment that you will use to measure volume. So a lot of people try to use beakers to measure volume, and beakers are actually really inaccurate. Scientists really just use beakers to hold their liquid on the counter until they're ready to use it. But a graduated cylinder is what you're going to want to use, and the problem with it is that water, or most liquids, have cohesive and adhesive properties, which means the water is going to stick to the sides of the container. So when you look at the side of this graduated cylinder, it's kind of hard to see in this picture, but the water level will actually dip down. And it's important that you measure it at the bottom of the dip. And the fancy name for that dip is called a meniscus. So anytime you're measuring volume and you need to read a graduated cylinder, make sure you read it from the bottom of the meniscus. This is just to help you remember that they are called graduated cylinders. The next 2 words that we're going to talk about are accuracy versus precision. And most people who are not familiar with science tend to mix up these 2 words or use them interchangeably, but they actually mean very different things. Accuracy tells you how close a measurement is to the correct or the true value. So for example, if you want to think about your chemistry test that you're going to take, the true value that you're trying to get, the correct value, would be 100%. That's what you're going to shoot for. So the closer you are to that 100%, the more accurate you are. Precision has nothing to do with how close you are to 100%. Precision is how close you are to yourself every time you take a test. Another word for that is consistent. It's how well you repeat yourself. So let's say that you get a 62 on the first test, a 62 on the second test, and a 62 on the third test. You're not accurate, but you could at least say that you are precise. You would also be failing the class, so hopefully you would come in for lunch to get some help. And here's the visual representation, just to help you. And the bottom 2 pictures are the most helpful. So notice the bottom right picture shows that they're both accurate and precise because the target, they hit the target 4 times and they were very close to each other. The picture on the bottom left means that they're precise because they hit the same area each time, but they weren't accurate because they didn't hit what they were trying to hit, the target. And the last thing for this unit is percent error. So percent error is a way of expressing your accuracy. It's basically a grade for the scientists to show how well they did with their lab. And this is the equation. Percent error is the theoretical minus the experimental divided by the theoretical times 100. And notice that around theoretical minus experimental there are 2 vertical bars. Those bars just mean absolute value from math. Most of you should be familiar with that from math. So absolute value just means that you take the positive value. So it really doesn't matter if it's negative or positive, you're just going to make it positive every time. The main thing is that you put the theoretical on the bottom. That doesn't help you if you don't know what those words mean, so let's write that down. Theoretical value is the correct value that you're trying to get. So before you do a lab, a lot of times you'll do a calculation first to figure out what you should end up with in the end. And that's called your theoretical value. Experimental is what you actually did get when you did the lab. So theoretical is what you should have gotten, experimental is what you did get. And if you take a look at the next slide, this is just an example. It says, in lab you measure the mass of your sample to be 6.2 grams. Reliable sources indicate the actual mass should have been 8.3 grams. What is your percent error? So on the top of the fraction, you just want the difference between them. And it really doesn't matter if you do 6.2 minus 8.3, or if you do 8.3 minus 6.2. You'll get the same number. Each one will be, one of them will be positive and one will be negative, but like I said, it's taking absolute value, so you just take the positive one. The main thing is to make sure that the 8.3 is on the bottom. So 8.3 is your theoretical amount, because that's what reliable sources show that you should have gotten. And then times 100, and this scientist got a 25.3% error, which is actually pretty bad for a scientist. You want to be as close to 0% as you can for your error. And that's all for this lesson. Thank you.